Hello, hello, ladies and gentlemen. My name is Nick, and today we will discuss a little bit about 1,000 bytes or 1,024 bytes, how is correct, and of course, why some GCSE books, books of computer science for GCSE and also some website put 1,000 bytes, not 1,024 bytes. In my opinion, and I'm a guy postgraduate in computer science with 20 years experience in computer science, um, it's wrong to put 1,000 bytes. It's good to put 1,024 bytes because we talk here about computers, science, so about computers. Okay, people will start now to say it's two types, two versions. A decimal type who's 1,000. 1,000 basically go next one, so that's why it's 1,000. 998, 999, 1,000, one, and so on and so on, so on, 99, 1,000 again, something again. So because it's decimal, it's a thousand. So 1,000 bytes, it's a kilobyte. 1,000 kilobytes or 1 megabyte, and so on and so on. In my opinion, it's wrong, and I will prove why. Because we talk here about computers, we talk here about computer science. So we need to understand about computers and how they think, how they store information, how they process information. So that's why it's wrong. It's very wrong to put 1,000 bytes. Also, you in the future, if you will be a software developer or IT professional, you will see you will lose data, a lot of data, if you use 1,000, not 1,024, because 1,000 bytes it's 0.97, something like that. So it's 0.03 minus, it's not one. Okay, so in this case you lose data. If do you realize 1,000 bytes is 0.97, so it's minus 0.03. If you go from kilobytes, because 1 kilobyte is minus 0.03, megabyte is 0.3, a gigabyte is 3, a terabyte is 30, and so on and so on and so on. Petabyte is 300, and so on and so on. So basically you lose a lot of info there. Look, we talk here about computer science, and it's 1024, not 1000, because we talk about computers, and computers goes in binaries in general. They talk in binaries, they think in binaries, okay? And we talk here about powers of 2. So that's why, it's 1 byte, 2 bytes, power of 2, 4 bytes, 16 bytes, 32 bytes, 64 bytes, 128 bytes, 256 bytes, 512 bytes, and 512, it's 1024 bytes, not 1000. Okay, we discuss here about computer science, so that's why, in my opinion, it's better to have 1024, not 1000. The same if you take from kilobytes in megabytes, it's 1, 2, 4, 16, and so on and so on and so on. So 512 with 512, it's not 1,000, it's 1,024. Okay, so I saw in books GCSE for computer science. I saw over the internet the same thing, the same thing with same errors, in my opinion. Okay, some people said it's not errors. Again, it's decimal style and binary style. Doesn't matter. We talk about computers. Okay, so a big issue is because, okay, we don't talk about something else. We talk about computers. Okay, and again, computer have binaries, have power of 2, and go like that. Okay, so look, here is one example. I will have another example for you if you want. This one, they said 1,000 bytes, it's a kilobyte, or 1,000 kilobytes, it's a megabyte, and so on and so on. It's wrong, in my opinion. Okay. Um, It's wrong to teach pupils like that for GCSE. It's not wrong um, to use. You can use both. That's why I said about both types, decimal type and binary type. But it depends by calculations. You will see. But to expose this, to explain this to a student, to a pupil for GCSE, and after that, the pupil, the student will go to university, for example. Okay, go A level university, and in all other books will be 1024. What the student will say? Is something wrong with that books or with what I learned already? You know, what I assimilate already. So that's why I said it's good to put exactly what is in technology, in IT, in computer science, because you will see IT professionals will not talk about I have a giga, 1,000 megabytes, so I have a giga or something. No, they will say I have 1,024 because if you use as a software developer or IT professional, you will use data, you will use information. Um, Also, I'll prove to you why it's better to calculate with 1,024. Okay, if you check over the internet, you will see Google say 1,024 for professionals. They will not say 1,000. And also another search engine. If you go, you will see it's 1,024. They will not say 1,000. Okay, if you put the memory size, for example. Okay. So I'm talking here about computer science. I'm not talking about plain mathematics or something like that. I'm talking about computer science. And also, you need to see in some tutorials when you go higher, you will see it's 1024 explained everywhere. So an ex-pupil who is a student now, probably will be confused. Oh, I learned about 1,000, now it's 1,024. Why? That's why, and I try to explain. That's why I try to explain now what is the difference. Okay, so basically, a kilobyte is 1,024 bytes. A megabyte is 1,024 kilobytes. A gigabyte is 1,024 megabytes. 1 terabyte is 1,024 gigabytes. 1 petabyte, it exists more than terabytes. Okay, 1 petabyte is 1024 terabytes. One hexabyte is 1024 petabytes. One zettabyte is 1024 hexabytes. One yottabyte is 1024 zettabytes. One brontobyte exists also something like that. Brontobyte is 1024 yottabytes, and 1 byte is 1024 brontobyte. If you lose 0.03 from a byte to a kilobyte, do the calculations how much you lose if you go in byte. For example, a lot. From a byte to a kilobyte, you lose 0.03. From a kilobyte to a megabyte, you lose 0.3 because it's another one. So basically 0.3. Megabyte, gigabyte, it's 3. So basically between first and gigabyte, 3, and so on and so on. So basically 330, 300. So you lose a lot of information if you will put in process for something after that. Um, Check when you have RAM. RAM, it's a random access memory. It's a memory, for your PC. When you have that stick of memory, you have a stick of memory long like that and put in your PC. Yeah, that kind of memory is never ever put it in 1,000. It's 1,000. Check on the memory, you'll see it's 1,020. It's 1028 megabytes, for example, 1 giga, or 1028. I don't know. So or 2 says there, giga, or 4 or 16. They will not say 3, 5, 2.5 something. It's exactly because it's in powers of 2. Okay, so that's why at the end 512 and it's the next one is 1024. Okay, good. So we saw all this, and now I want to show you also how I calculate using my phone. You have a phone. Good. Take your phone, and there you have a calculator. Okay, a calculator is in multiple modality, multiple ways. I mean, you can use a standard a calculator, standard style, or you can use a scientific, or you can use for computers and for IT guys, for IT professionals. And I will show you right now how it is. It's very nice to see all this. Look what I have. I have a calculator, okay, and a unit converter. So kilobytes in megabytes, 1,000 kilobytes. It's 0.97. It's not 1 megabyte. 1,024 kilobytes. It's 1 megabyte. Can you see? It's not made by me. Look there, calculations. A thousand kilobytes is 0.97, so basically 0.03 less than what you learn in GCSE computer science books. So 1,000 kilobytes, for example, it's in put in megabytes, put it in gigabytes is 0.97. So that 0.97 remain. Doesn't matter because it's from kilobytes to megabytes, from megabytes to gigabytes is the same. Okay, it's about number. It's about mathematics. I know in UK it's a little bit hard with mathematics, but in general this is about. If you put 1024, like I said, it's 1. Can you see 1024 bytes? It's 1 kilobyte. 1024 kilobytes, it's 1 megabyte. 1024 megabytes, it's 1 gigabyte, and 1024 gigabytes, it's 1 terabyte. So I think you saw this, and you saw why it's about 1024, not about 1000. Till next time, see you. Bye.